All right, so let's take a look at power series. Here's where you want everything to this where you have to get full marks, right? Power series, right? You need to remember how to expand these things out, right? So in power series, if A and B are values, you plug in A and B to the formula, right? But what does N2, what does this mean again? This means NC2, right? So you go into the function NCR when you plug in the values before and after. That's okay? That's NCR. Right? You need to be able to expand that out properly. Know that binomial expansion is used when n is a whole number. When n is a negative or a fraction, we have to use a different version, right? You're not going to be able to find factorial like that, right? How to fix it. Make a mistake. Right? You can still use the expansion, except we're going to have to find a value, right? I'll show you this now. Instead of finding the entire expansion, we can use the general term. So for example, if you figured out, well, here's what. Like in this example here, finding coefficients of x to the 6, instead of going and doing the whole expansion, what you could do is use the general term and then find R's. Once you figure out R, you just plug it in here and you'll be able to get the coefficients of x to the 6. Right, here's an example. This shows you what to do. So if you look here, what we did is we don't know R, right? We don't know R, right? But we know that A is 3 and B is minus x squared. So plug in A, plug in B, right? And then we plug in N. But the problem is we don't know R. So what you normally do, right? What you normally do is, for example, you would say this. You would say 4 minus R. Sorry. You would say that here's the only part of x, right? X to the power 2R has to be equal to x to the power 6. So what that means is 2R has to be equal to 6. So R has to be 3. And then you plug it in the formula and you get a coefficient. Okay with that? Right? So pull out all the x terms. Pull out all the x terms and then equate it to what you want to get. Right? And then solve for R. Once you have R, now we can just go to the general formula given here and expand it out. Right? What would happen if you say independent of x? X is, well, R is 0, right? R is 0. If you say independent of x. Right. Sometimes now, whenever n is negative or is something rational, we have to use this formula here. Right? That's the formula we're going to use to find NCR. So for example, if I ask you a half NCR3, if I ask for a half NCR3, right? N is a half and R is 3. Okay? So all you have to do is you plug it in, right? Underneath is 3 factorial. So if you have the number 3 underneath, you have to have 3 products on top. So it will be a half by a half minus 1 by a half minus 2. If you have 4 factorial, you should have 4 products on top. That's okay? That's how you know when to start. Right? 1, 2, 3. If it go 4, you do 1 more. Everybody okay with that? And you can work that out, right? But if you put a half C3 in the calculator, you'll get error. Right? Although there's a way in the Casio to flip it so you'll get it there, but times. I don't know. That could be a homework. I know how to do it with calculator. Right, Emily? You do a video and send it on, right? Let's go up. Okay? Everybody okay with that? Right? So all you have to do, as I said, when it's 1 factorial, that's what you do. When it's 2 and 3 and so on, and you work it out. Please be careful. Like questions like this. Remember, sometimes might forget, but A is 1 and B is minus X. Okay? A is 1 and B is minus X. Okay, so that is your binomial expansion. Taylor, this is Taylor series. I know that some of the expansions, right? Some of the booklets, the answer booklets, the formula sheets, just give it Taylor series. Some don't. I don't know which one your school have. Right? So my advice is still learn Taylor series. Right? Some of them have Taylor. Well, you don't need Maclaurin if you have Taylor, right? Why? If you have Taylor, to get Maclaurins, A is just 0. That's okay? So how do we do Taylor series? Really easy. They'll give you a function, let's say the function cos x, and they will tell you that it's going to vary around x is equal to some value A. All you have to do, find f of A, put it in there. Write x minus A, you're not working that out there, leave it as it is. And then find first differential, then plug in A, then write this, second differential, plug in A, third differential, plug in A. What just makes this hard is that sometimes the differentiation hard. But there's reward here, right? You'll get like 14 marks, something pretty serious. Yeah. Yeah, you'll get like 14 marks, something. You will see questions like that. But that will make up for like the hard questions in the same way as you got 1 mark. Okay, so here's an example of Taylor series where you had to expand root x. So you plug in your tree, you differentiate, plug it in, and so on. First differential, second differential, third differential, and then you plug it in and simplify. Please notice that you will always end up with these x terms, right? That's okay. And Maclaurin's. So these are real nice something. If you can write over everything here, it's 60%, 70% that you read up. Right? Right? Maclaurin, same thing, you just plug it in 0. Have you give it up? Alright, so let's try some power series now. Before we do each one of these, right? Let's do some power series. Let's start with, I know it's a lot of the year. I mean it's a lot of the year now. Let's try 1995. Start here now. That's the more, that. Anybody writing these things neatly, like have all the answer on a paper or somewhere, or on the iPad, everything like save. Yeah, I keep fed up every year and I write down solutions. So I'll just use that stuff and just I'll post on some solutions for living for example. But you have them if you need them. You have an next option. Huh? I have these already. All right. So obtain the binomial expansion up to 1 included. So what does that mean? You can use general term, right? You have to expand everything out, right? And because it's a quarter, you can't use NCR. You have to use the formula, right? So go to the summary and use the second version to expand. Yeah, MCL. MCL as well. Yeah. What if you? There's nothing on it to get. That's my pretty board. Good part. That'd be good part. I forget that. Four. You're doing four. Okay, but we can take on something, right? No, you're good. That's right. Yeah. Huh? So let's show it up, I think. Like, you know, two. So find it, change it back to the earlier. If I had used all the templates, or not?
Yeah, it was.
Because it's 15.
Yeah. That's like, for sure.
And so this is what.
Yeah.
I mean. I don't have that here. Alright, move on, eh? And they said, state the values for which the expansion is valid. But remember, what x is? Okay. That's not true. I'm gonna start here. Right, so they want the expansion. Sorry. Right, let's understand that. You'll see a later part. Next week. So look at the next page. Okay, we have about the hand, let's talk about. Right, what's a quarter? What's a quarter? Guess what's getting coefficients there? Everybody will think for the coefficient of x. We are got to the coefficients of x. 5-1. 5-1. 5-1 16. 5-1 32x, and the next one is what? 75 over 49. Or 49. That's okay? That's all they're doing, right? Everybody okay with that? See if we should find it now. So you can that formula there, right? Whenever it's a fraction or negative. So you sorry? If you put in minus 5x in front of it, or say you did minus 5x there, well, it should still go down. And if it is same, right? So you use minus 5x plus 16. You get the same thing. Right? Underneath that, they ask for hence state the values of x for which the expansion is valid. What is a binomial valid generally? Mod x is less than 1. Right? The modulus of x is less than 1. So, how do we work out that? Going down, right? Right, yeah. So state the values for which the expansion is valid. So what are we doing there? I solve it. This is generally, right? Or you do the solve it. That the send is 16 minus 5x equal to and then solve for. Right? So you solve 16 minus 5x equals to 0. Solve for x. That will be what? 16 and 5. That's okay? So this solution set is what? No. We have to state the values. We have, so you have to state now the range that we will form. Right, so you're going to get mod x is less than 16 or 5, and then your remember what modulus is? When x is more than 0 is what? When x is more than 0 is stay as it is. When x is less than 0 is when x is less than 0 is less than 16 and 5, so the symbol will change, and you'll get x's greater than minus 16 and 5. Okay, so all you have to do is find the values on the inside. I got the 16 and 5 from here earlier. You know, let's try again. Use the expansion in C part 1 to estimate. Use the expansion in C part 1 to estimate the value of right. Use the expansion obtained in C part 1 to estimate the value when x is 3. So what you'll do? You substitute x is 3. Then what you're gonna do? Okay. 1 point. 6. So let's plug in 3 the expansion from part 1, right? Yeah, but in a short learn 3 terms. Yeah, plug in x in there. Question. Or we might see one like it. But suppose they ask it, let's just say they ask it, estimate a value for that 11 to the power quarter. What you do? What you do? If they ask estimate a value for 11 to the power quarter, what you do is you check and see what x value they will make it 11. X is 1, right? So when x is 1, you plug it in the expansion and work it out. But give it up. So sometimes they do give you the x value and ask you to figure it out. Let's go again. Yeah, you plug it in. No, I use another bill. Yeah, we have about 50 and I'll get it. I mean 40. Right, next one. Oh, that's intermediate, sorry. Intermediate, AP and GP, we do all that already, right? We just have the intermediate is what we done 2024. We did everything in 2024. Everything. Anybody write up nice? Wait, what that is? That's what I'm looking for. Part B. 3 part A was a Mark. Okay, right. B and C is Mark Lawrence. You sure? 2024? Taylor. Do this Taylor now that part B. Up to x squared. Right squared. Great. Right, 34, number 3, part B. Same here. That, right? What's the best way to write it so you can differentiate it? 1 minus 2x3 minus 1. Nice. Online, you all hearing now? You all see the board? How about Wi-Fi now? Wi-Fi drop or Wi-Fi drop? What's good? This class. You in this class? You in that class? You come on to that class, I might increase the.
Hey, भाई, must be this smart, right?
Alright, I'm not sure what happened then, huh? Which Wi-Fi drop, boy? And again, back on there. Wait, so that's something that's mine. But the Wi-Fi down? Or the one working there? So this one connected to the same old retarded one. Huh? That's all right, let's do one here. Right, maybe it's not us the word. Right, so it might start back to work now. All right, let's see if all right, let's see if it work. Online, you'll see what now? Well, I'm not writing on the board, but you all see the screen, right? Yeah, okay. Right, so it's a Taylor. So the first thing that we need to get is f of x, which is 1. Well, I'm not writing it like that, right? Right, that's like 1 minus 2x to the power of minus 1. F of 3. F of 3 will be minus 1 over 5. But I get up to f of 3. Just plug in 3 for x, right? 1 minus 6 is 5, minus 5. F prime x will be 2 by 1 minus 2x to the minus 2. F prime 3, how much you got for f prime 3? 2 over. And one more because it's up the square, right? So do the same thing again, bring down the 10 over 8 by 1 minus 2x to the minus 3. F double prime 3 is how much? Minus 8 over 125. Huh? Yeah, look at the formula. Look at the formula. No, I think this one. But this one a different connection. You understand?
Yeah, you will understand.
Yeah, so I read teachers.
Yeah,
That's one thing, but it's one people.
what at all them.
No, that one different one. That was. But this is in class.
But drop everybody. Drop only downstairs or
Yeah, but for who? Right, just write the last part, mother. Right, so yeah, so this how there's no this how there's no Nikolai based on the expansion. Right, up to the x, up to this square two. What I get up? Yeah. What I get up? Kanaya, you get up? Right, nice. So you just plug it into the formula. Please don't forget what's that thing called it? Forget. Oh no, you can fix it. Remember, it will be 5 minus 3 factorial over, sorry, squared over 2 factorial, right? But see, it cancel it off already. 2 cancel with it 8 and give it 4. Right? Let's go again. That was 2024 in full, right? Still have more in this one? Yeah, you come back and do that. You right that one before. Yeah. Right? Let's go again, 2023. I want to do it, but I don't want it.
Yeah.
Try this fast. Find the coefficients of x to the fourth is 2023. Oh, you have 2023. Try that eh? Right, they only want x to the fourth, right? So you're only going up the way. Huh? What you want to do? You sign up or you bring up the one underneath? Bring up the one underneath, you get minus 2, right? And you only go up to the 2 without getting x to the fourth. So they had to go up with x to the partial, then do what? Partial functions and then yeah, but then what the point are you going to expand the minus one? The power of one, yeah, they have to go to them and add it. So you're doing 1 minus 2x multiplied by 1 plus 3x to the minus 2. And you expand it 1 plus 3x to the minus 2 all the way until 4. Right, I'll send the Google Chrome, right? What do you want? Well, it's fun, quick. Yes. Remember only one thing before. So you don't really have that. Only One down, one down, one down, and then but it would be.
Yeah. Right, so we should have something like this. 1 minus 2x. Right, it's to the power minus 2, right? So that'll be 1 to the minus 2 plus minus 2. As I said, you don't really need these first few terms, but we will still do it. You'll understand why I'm leaving out the first few terms. I'll write it out. I'll write it down and show you why, right? No, I don't have enough space to write it like that. Give me the NCR. Yeah. And that's right, not like I don't have enough space to put the whole thing. Right, but in negatives, I'm not using it. But this writing it like that, because I don't have space. I'm gonna show you how to work it out. I don't have any space now, so I can't write down the whole thing that I'm supposed to use. Right? Huh? Why I just told you this? Because for the next day, you don't understand why I'm leaving all the first three terms. Right, but remember you can multiply by one. I'm gonna show you the whole thing, right? Alright, anybody can help, huh? You'll end up with one what? What's the x term? Anybody work out the x term? Please remember that minus 2c3 will be minus 2 by minus 2 minus 1 by minus 2 minus 2 all over 3 factorial, right?
That's the way you work it out, right? The long way. Okay? Alright, anybody can help me? Just help me get the expansion then up, please. Yes. What will be the coefficient of x? Minus 6x. What's the coefficient of x squared? 9x. 9x squared. Plus.
Yeah. Plus
Next one.
minus 108.
Minus.
108.
Minus 108 x cube and last one. Plus. Right, watch now, Nikolai, if you didn't understand, right? They are only interested in the terms that given x to the fourth. So 1 by this, by this, by this, by this cannot give you x to the fourth. So we need 1 by this. That's okay. And then look at this. 2x by this cannot give you, but 2x by this will give you x to the fourth. So that is why we needed the fourth term and the fifth term. What is the first term? You okay with that? Right? So we didn't, if you had used the fourth term alone or the fifth term alone, you would have left out a value. Okay? So yes, we don't need this. We don't need the first three, but we need the fourth and the fifth. So you have to always take it into consideration. No, I can't use the NCR formula. I use the expansion of the NCR formula. Right? If you turn the page on the summary, you'll see it. Right? So the answer will be 405. So the answer will be 405 plus minus 2 by minus 108. How much is that? 260. 260. A mass plus, right? Oh, I mean the whole thing.
Yeah, 621.
621, yeah. That's what I meant. 621. Are you okay with that? Are you okay with that? Let's go again now. We'll just watch it all in, try it. That was a real hard year. Yeah, sorry. What's that? Which formula? Yeah, I'm sorry, in the expansion of the binomial. To get 1 minus, to get 1 plus 3x to the minus 2. Apply into the expansion of the binomial. We're not sure about it. Right, turn the slide, turn the page. In the summary, turn the page. Look at when R is a negative and when R is a fraction. Yeah, that's why you. I think they'll give it up to common. Huh? Huh? Yeah, it's the same similar thing. I think they'll give it up. And they expand it out.
Yeah. And I think it was 1 plus x to the power x.
Yeah. But oh, okay. All right, well, you had to learn it. But I think they'll give you a form. I think I saw in our formula sheet today. Remember you're supposed to get a sheet as well. Huh? You're supposed to get a formula sheet as well.
Yeah.
Oh, okay. All right, next one. Maclaurin's expansion. Maclaurin's expansion up until the third non-zero term. Maclaurin's expansion until the third non-zero term. This will be about 7 marks. Huh? Oh. 23, McLaurin. Yep, put up rule here, yeah. Right, go on, I'm just fuck with well, you guys, madam. I don't know anymore. And you guys, how do you probably help you? Huh? Huh? What's the right in back? Well, calling for an answer. Hi, ready? Want to get through? So when they say non-zero, right? When they say non-zero, mean you keep going until they get to be about 5, right? And there was 5 times. What time did we go? 5 times, no? 4. Right? Including the 3 non-zero terms, right? Well, provided that when you're plugging 0, you don't get 0. So you expand it. You're gonna keep going until you get 3 non-zero answers. That's all. So you're doing the same thing. F of x is equal to right? So the first one giving him 2. 1 squared is 1, 1 plus 1 is 2. Oh, sorry, 0, right, sorry. 1. So you get 1. So that's the first non-zero term. You have to go again, right? Or you differentiate in the Shibish? Huh? Just do it for me now. 1 plus x squared by what's the differential of plus? Minus sign. And then what's the differential of 1 plus x squared? 2x, right? So it's 2x plus x. Then you find f prime 0. Sign will be 0. So you get 0 here. Second C. Right, so that'll count. You need to get 3 at least. That's non-zero. Huh? 3 terms that do not include 0 yet. So you can't stop until you get double prime x now. We had to use product rule again and again.
Twice.
Oh Lord, leaving that out. Read all that do. So you gotta use product rule again, right? If I can't fit this here, I might have to go on. Huh? That's true. I wanna write it back and give you. Huh? Well, better, yeah. Huh? I will see. I just looking at our exams. Next week is physics. Next week is physics, and then the week after is CTEC maths and things. So I just looking to see how things will go. Which one is that? It's Saturday. Yeah, man, Friday physics. And physics in the evening. Yeah, but even if I do it Friday, or they're gonna finish exam. Huh? Yeah. I think next week, or they're gonna have to study for that physics. Where am people on? Yeah. Huh? Where you want? We've done all the way.
As far as PLC, we go the class.
Yeah, I'm sorry, I'm central.
And we still outside. But I really can't.
You got ready? That's right. Right, so f of x is equal to 1 plus x squared cos x, right? Right, so we'll end up with right, so we find f of 0 is 1. Right? F prime x will be equal to 1 plus x squared minus sine x plus plus 2x by cos x. F prime 0 gave us 0. Double prime x, right? That'll be 1 plus x squared minus cos x plus 2x by minus sin x. So that's product rule just for this alone. And then product rule for here is 2x by minus sin x plus 2 by cos x. Right? F double prime 0 now. This will be 1. Sorry, minus 1. When I plug in 0 here, I'll get minus 1. This is 0, this is 0, and 2. So I get minus 1 plus 2, which is 1. Okay with that? So that's first order. 1, 2. Right? If you want, we can make it look a little nicer. Yeah? We can pull out. We can add up these two here. That's product rule for sure. Here we can add up these two, and we will get 2x plus 2x is 2 of that. So that'll be 4x minus sin x plus 2 cos x. Ah, 4x and 4x, right? All right, and then we differentiate again. Right, hopefully it work out. 0. Oh gosh, 0. No, I fed up all them. I guess 0 again. 7 marks, I taken my little 3 marks here and I done it. We gotta go again for real. Somebody write this meter, please. Wait, somebody I got disconnected again. Online, you're there still, right? Yeah. Okay. Yeah, it's taking a little while. What's up? What's up, Arian?
Yes, we.
You know, so the committee, I see there now, so go one time. You gotta pay, go ahead, right? Minus 6x minus cos x. Sorry, I get lost there. This plus this. 4 minus 2 is 4 minus 2 is 2 minus sin x, right? Anybody get it? Anybody reach here? 34?
Yes.
Anybody get out -7? Huh? -11? Oh Lord. Today one. This is one. And if I leave out a term, boy. No. You say again, they get 11. Here was supposed to be -4. This is -6. Yeah, that's correct. -11. Right, -11, correct. Anybody get -11 online? Yeah, all right. And last part, we write f of x is equal to what is 4 factorial again? 24. Anybody get that? Final answer? Yes, that works at mark, right? That 14. That should be at 10, 11, 12. All right. I'll put up there. Let's take a look at roots, right? That was very long. Right? Let's take a look at roots now. Are you okay with this? All okay with it? Yeah, just a little long, right? Huh? Yeah, that is long. Huh? Three. No, this is 9, but now it's not. You are studying, that was the year we had differential PMI and stuff. So they will something about it, there's something about it. Alright, log back in there, log back in. Let's take a look at roots, right? Are you ready?
Yeah.
What's your name? Somebody write it down, nice man, I write it down. Yeah, and who will say, anybody write it? What do you write? So you don't have them, no. You don't have them by year. Yeah, I them. Alright, let's go now here. Alright, Idan, what's your name? Idan, watch your pen and don't talk too loud, remain falling, right? So we need to be able to estimate roots, right? Already, what's your name? Nikolai, earlier, back. What's your name? Huh? Alright, so we need to be able to estimate a root, right? So if a root lies there, we can use intermediate value theorem to show that a root lies between particular intervals. All we have to do, find f of a, f of b, multiply them. If the value is less than 0, then a root exists in the middle. All right? Intermediate value theorem allows you to determine if a root exists between two particular values. Is that okay with that? All right, so please remember IVT, right? Yeah, intermediate value theorem. Right, so if you see IVT, that's all you're looking for. That's all you're looking for. Plug in the lower limit, plug in the upper limit, and multiply them. If you get something less than 0, a root exists. All the time, yeah. These are technically the 4 ways in which we can estimate the actual root. So after we figure out our root exists, we need to be able to determine an estimate for the actual root, and we have all 4 of these to learn. Any of these could come. All right. Let's start with linear bisection. So if you look here, here's a little diagram of how it works. Right? A little diagram of how it works. All you do, take the limits, add them up, find the midpoints, and take that new limits with the one that satisfies intermediate value theorem. And you keep going until your answer is the same to a specific number of decimal places. If the question says the one with the 2 decimal places, you have to keep working out to 3 and then round it off until you end up with 2, until you end up with the values being the same 2 decimal places. So watch this here. Right? These are your 4 steps, right? C is equal to A and B, f of C is positive, C is closer to alpha, so your new boundaries are A and C. And you keep doing that over and over. All right? And I want you to remember this little thing underneath here. New boundaries allow IVT to hold. Since f of A is negative, f of C and f of C positive, then the new boundaries will be A and C. If you chose B, f of B is positive. It will not satisfy intermediate value theorem. Right? So you have to remember that every single limit, every single interval must satisfy IVT. Okay? It must satisfy IVT. All right? So whenever you use the formula in everything you're doing, linear interpolation, linear bisection must always satisfy IBT. All right. So watch it here, right? These are the iterations that you take. Those are the steps that you take, right? Watch this example here. Watch this example here, right? First thing we do, we take f of x, we plug in the values, so we see which one positive. In this case, that negative and the one positive. F of 0 negative, f of 1 positive. So therefore, by IBT, we know our limit exists. Now, let's do 2 iterations of the linear interval bisection, right? So interval bisection, using the formula, which is here. Please recall that f of 0 is minus, f of 1 is plus. We apply the iterative formula, the iteration 0 plus 1 on 2, we get a new midpoint. Right? Find f of 0.5, and then you recognize it negative. So because 0.5 negative, we don't want f of 0 anymore. We're going to go with the negative and the positive. And then we perform it again. 0.5 plus 1 divided by 2. Then we find f of 0.5 and we got 0.3. 0.3 positive. So we take in the negative, which is 0.5, and the positive, which is 0.75. All right, you will always recognize that these two are opposite in sign, right? Everybody okay with that? Then you can go again and again and again. All right? Yeah, this question said 2 iterations. Right? Here's something to look at as well. When you work out this, right? When you work out f of 0.5 and f of 0.75, if your value is not getting closer to 0, something wrong, right? You probably add wrong or plug it in wrong. It's supposed to be getting closer and closer to 0. So if you end up with 0.41, something wrong, right? Your value is supposed to be getting closer and closer to 1. That's 0. Perfect answer is what? 0. Perfect answer is 0. If you find f of something and you get 0, it means that you actually find the roots. All right. Next, linear interpolation, slightly harder. You gotta remember this, right? That help you there, right? You gotta learn that. What does the modulus mean? The modulus means that you're only working with the positive value. All right. So here we have an example by IBT. Sorry, by linear interpolation here. Right? Notice we only take the positive value, right? Only taking the positive value. You work it out, you got 1.372, right? You found f of 1.372, we got something positive. So we go in with the positive and the negative. Are you okay with that? Same thing over and over. You just have to remember the formula for bisection and the formula for interpolation. Are you okay with that? Huh? Measure. I think which one? This one? So I using the formula, right? These are the limits, right? This is A and this is B. This is f of A and this is f of B. Okay, that f of A and f of B. Sorry? Anything can change. A can change or B can change. Why me? No. Not the interval, you know. When you work out f of the interval, that will be positive or negative. What's it right here? Watch it right here. This is f of x, right?
Yeah.
And the interval is 1 and 1.5.
Yeah.
When you plug in 1, you get a positive value.
Yeah.
When you plug in 1.5, you get a negative.
Yeah.
Right? Right. Now you're going to use the formula and you're going to end up with 1.372.
Yes.
Right. So when you work out f of 1.372, we got a positive value of 0.207. So now you're taking the 1.372 and the one that was negative, which is 1.5. Okay, so you're taking the limits that will give you a positive and a negative. Everybody okay with that?
Yeah.
That's all you're doing. And lastly, Newton-Raphson. Newton-Raphson is this formula here. Again, somebody formula she just give it up.
Yeah, this one.
Right? Newton-Raphson is that. General formula underneath. Okay? As a general formula for Newton-Raphson. Right? If you want to come up with an iterative formula, there's an iterative formula. It helps define like x to one thing. Right? But basically all you're doing is put n is 1 and put n is 1 and you'll get x2 equal to x1 f of x1 f prime x1. So it means yeah. Right? What that means is that you have to be able to differentiate. Okay? You have to be able to differentiate to use Newton-Raphson. Okay with that? So you have 3: interval bisection, interpolation, and Newton-Raphson. Iteration is technically the same as the one. Just give you a formula to work with. Huh? They can actually do the proof as well, right? So what I did for you here is I showed you. Yeah, I learned that. Never come by proof here. Right? Take it out, you can use Newton-Raphson proof, and I did it out here for you, right? Yeah, I learned that, right? All right. So now we just stick. Yeah, we can do that now. Let's start with Newton-Raphson. Huh? Yeah, direct. Let's start one time now. Right, use two iterations of Newton-Raphson where x0 is 0.3. Right? To calculate 2024. Right? So I'll do this on the board here, right? No, what's somebody to write it down? I just took a picture. So we got the Newton-Raphson. Do me a favor, write down the formula. Write down the formula for Newton-Raphson, right? Hurry up. For those who can do it, try it fast. Those who can do it, come back now. That is 3x cubed here. I'm coming up. And it's like, yeah, it's done. No, well, they start at 0, so you have to start at 0. That's and then 0. All right, so what do you get here? Right, so x0 would be 0.3. F of x0 would be 3 by all over. You plug in plug it in here. Then you work out the whole thing. Right? This is f of 0. And this is f of f prime x0. Right? Yes. And in this one? Yes, stop this over and come up here. Oh yeah, work this out fast. Huh? No, they go like 2 decimal place, so then this is 1. What is the question? Any particular decimal place?
Yeah, 0.2626. Yeah.
0.2626.
2626.
No, we're not going all the way. If this is 1 decimal, we can go to like 3.
Yeah, 0.26.
26. 3. Then you go again. Right? Because remember you had to plug that in, right? Are you okay with this? Right? All we do is we just plug 0.3 in here and here. And here. And work it out. Huh? 268. Anybody else? 3. Pick up your head. Anybody else got? Anybody else got it? This? 3? Oh, okay. So because the answer was because they started with 1 decimal, we can get them like 2 or 3, right? And if you go to 4 if you want, right? Next one, x2. X2 will be 0.263 minus 3 by 0.263 cube minus 4 by 0.263 plus 1 all over 9 by. Right, the good thing with this is that we don't have to keep differentiating, same function we use it. Minus 1.
Oh, yeah, so 0.2.
0.3.
Yeah.
Anybody else get up? You got it? 0.309. Huh? Yeah, I feel like it should be something like that. Yeah, because it should be starting to converge. 0.2. All right, well. Huh? If you use the full thing, it should converge.
Yeah.
Right, so that's it. Yeah. That's why they say twice, but one like it converge. So the two decimal places, the root is 0.26. All right. Let's go again now. How many more? 24? Number 4 now. Right, they want 3 interval by section. Hurry up. As we then go after, yeah, that's a way to work it out so you can help, all right? Huh? Right, so we're gonna do interval bisection. They want 3 iterations, right? Right, they want 3 iterations. So first thing, f of 0.2, how much is that? Minus 3.14. Well, f of 1 is what? Right, so by IBT at least one root exists, right? And then in part 2, they want us to do interval bisection. So I'm going to find the first one, which will be 0.2 plus 1 all over 2. 0.6. So I want to find f of 0.6. How much is that? Yeah, plug in 0.6 here. Negative 1 point. Right, and then so, right, so by IBT, the new limits are 0.6 is negative, so it replaces this one. So I'm going to take 0.6 and 1. Tell me again earlier.
1.192.
Positive.
Yeah.
1.192. That's really important, otherwise you'll get wrong, right? So you're taking the positive value. So now your limits are 0.21, 0.6. They want 3 iterations, so you're going again. 0.2 plus 0.6 divided by 2 is 0.4. And then you find that, which is anybody else?
Yeah, yeah.
1 point,
1.1.
right? And then by IVT, we taking we taking the negative, which was 0.2, and we go in with, sorry, 0.2 was negative, sorry. So we go in with 0.4 because it's negative, and the positive was 0.6. Right? By IVT, that will hold. Then we go again, 0.4 plus 0.6 divided by 2 is 0.5. So we go in again, and you'll recognize that the limit's getting closer and closer, right? Yep. Serious? Well, good. Right? So therefore, the estimate is 0.5. Alpha minus 0. Yeah. That's a real good estimate. It's like you actually question and you have to guess the exact thing. Real good estimate. Can I go again? What do you know? Do you know next one now? I can't remember it. 23. Last one, because at least let's give it a look at some. Let's give it some. All right, try this one. Try that. It's looking hard, but real simple. Try that there. Show that that is a suitable iteration of that. Basically, you're just trying to make theta the subject of the problem. And it looks like that, right? No, I don't have good notes on it. All right, just do that last one and we're done. I think I got time, right? Yes, sir. All right, last one here. So when you see questions like this, right, there's normally give you an equation that you have to make theta the subject of. All right. So in this case, you see it there. You want to make theta the subject, right? So remember that cosec is what? Remember that cosec is equal to 1 over sine theta. The right hand side, we can make it look a little bit better than that. That'll be 8 minus theta squared on 2. Right, so I just find the LCM now. Then flip it over. I'll get sine theta is equal to 2 over 8 minus theta squared. Let's found the LCM on the right side. And then theta will be equal to sine inverse. So all you have to do in questions like this is just make theta the subject, right? One of the theta. Look at your answer and you'll figure it out. Look at your answer and you'll figure out what you have to make the subject of the formula. So you just make any theta the subject and you're good to go. Right? You don't have to get all the theta on one side. There must be a theta on the right side because the iteration. Yeah, and be able to put in a previous theta. Everybody okay with that? So when they say iteration, this is what they mean, right? You get an equation and you go backward. Yeah. Full second is one on side. Full second one on side. Right in there, yeah. All right. All right. We will stop there for today, right? Right, remember, I'll give you the all night.